Hi everyone, welcome to another day of notes. Today we're going to be talking about parallel and perpendicular slopes. So let's go ahead and just jump right in. So starting with parallel and perpendicular lines, okay? So we have pretty much been exposed to parallel and perpendicular in a graphic sense, meaning that we know parallel lines, which is denoted with that symbol, two lines next to each other, are lines that don't cross, okay? They don't cross. But algebraically, we need to know something else. So visually, if we don't see the actual lines, we could tell if two lines are parallel based on the equation, okay? And parallel lines will have the same slope, okay? That's going to tell us that those lines are moving in the same kind of direction. They're moving at the same pace, up and over, up and over, up and over, and all that stuff. So they don't actually cross. They never get closer and closer together. So this is what we really need to focus on today, is that we're going to be focusing on the algebra part, that the equations of those lines will have the same slope. Okay? Perpendicular lines, which is denoted with this little symbol of two lines that are crossing. They're lines that cross at a 90-degree angle. Oh, I forgot to write cross in here. Sorry, don't cross. Okay, perpendicular lines do cross at a 90-degree angle. And if you have a protractor, you can measure that 90-degree angles, but just by looking at it, it is kind of hard to tell. So algebraically, we use that a lot more often because that's a little bit easier to tell. So algebraically, perpendicular lines will have opposite reciprocal slopes. And they need to have both opposite and reciprocal, which means they got flipped, like they're flipped of them. Reciprocal. There we go. Slopes. So we are going to be focusing more on the slope part today because we are not in geometry. Sometimes we'll see graphs, sometimes we won't. So we want to focus on the algebra part, which are those slopes. Okay? So that's how we're going to focus on telling if something is parallel or perpendicular based on the slopes of the line. All right? So, example 1, we have some graphs. We're just going to start reminding ourselves how to find slope and then how we can write the parallel and perpendicular slope. So this first one's just asking for m, which means it's just asking for the slope of this graph. So remember, to find slope, you're going to use your 2 points, and we're going to do rise over run, okay? Rise over run. So my rise, I'm going to start on the left side. I'm going to go up 5, okay? So my rise is a positive 5. And then I'm going to go to the right 5 spaces as well. And going to the right is a positive motion. So my run is also positive 5. Then I need to simplify it, okay? So you can put this in Desmos to simplify it. It will always give you the simplified fraction if you click that little fraction button. But 5 over 5 simplifies to be 1. Okay? So my slope is positive 1. The parallel slope is going to be the exact same slope, so the same number. Okay? So it's also going to be 1. Now, perpendicular is the opposite reciprocal. So opposite means it's going to be the opposite sign. So because this was positive, this guy will be negative. Okay? And then reciprocal means that you're going to flip the fraction. So sometimes it's helpful to write out what this is as a fraction if it's not already. So this is really 1 over 1. And then flip it upside down. So if I was going to flip this around, all it would be is 1 over 1 again. Okay? And then that new fraction, that flip version of the fraction, we still have to simplify just in case. So this can be simplified. And the the perpendicular slope is -1. So it's not just a change in the sign that it looks like here, it's also because we flipped the fraction. Let's try this one. Okay, so we have our 2 points, so we're going to do rise over run. So I start on the left side, I'm going to go down 2 spaces. So because I went down, that's a negative motion, so my rise is -2. And then I will go 1, 2, 3 spaces to the right. Going to the right is a positive motion, so it's +3. And then I want to simplify this. If you put this in your calculator, then just hit the little fraction button next to the answer. It will change it to be a fraction of -2/3. So it was already simplified, it just moved the negative sign to the front. Okay? If they were both negative, it would change it to be a +2/3. But because you only had one negative sign, we just move it to the front. Okay? So my slope is -2/3. My parallel slope will be the exact same. Another -2/3. And then my perpendicular, sorry, I'm getting stuck on that word. Perpendicular slope is going to have the opposite sign. So it's actually going to be a positive. And it's going to be a flip of this fraction. So instead of 2/3, I flip it upside down. So it becomes +3/2. And you don't need to write the positive sign, but my perpendicular slope is 3/2. Okay? So now you guys are going to try these two on your own. You're going to find the slope, the parallel slope, and the perpendicular slope of both of these. This one, you can pick any 2 points on that line. Does not matter which one you pick. This one, I just made it very, very blatantly obvious what you're going to do. Okay, so pause the video and try those two. All right, so we will go over the answers to those. Try on your own. Let's try find the slope of the points, and then we're going to do parallel perpendicular as well. So for this one, they gave us 2 points. So we need to find the slope. So to find the slope, just remember you're going to do y2 minus y1. We did this before break. Over x2 minus x1. So I like to label these just so I can keep them straight. So this will be my x1, y1, x2, y2. So I'm just going to plug those in. So I've got 3 minus 4 over 6 minus -1. So I just go ahead and simplify. 3 minus 4 is -1, and 6 minus -1, because I have 2 negatives, means I'm adding, so that's 6 plus 1, gives me a +7. If I put that in the calculator to make sure it's simplified, it'll spit out -1/7, which is what I want. It just moved the negative sign to the front, which is helpful for the next part. So my slope is -1/7, which means my parallel slope is also -1/7. Okay? Also, by the way, if you leave the negative in the fraction like this, I'm not marking you wrong. You're fine. Now for my perpendicular one, it has to have the opposite sign. So this one was negative, so this guy will be positive. And it's the flip of the fraction. So instead of 1/7, I'll do 7/1. And I want to make sure this is fully simplified. 7/1 is just 7. So I could just write my answer as 7. If you do not simplify your fraction, that's where you're going to lose points. Okay? So make sure you always simplify. So now you guys are going to try this one on your own. Go ahead and pause the video and give it a try. Okay. We will go over these answers in class. And our last thing about slopes is finding the slope from the equation. So just like we've been doing, we've been identifying slope, the parallel slope, and the perpendicular. So now we have an equation. When we have an equation like this where it's y equals a number times x plus or minus a number, that's slope-intercept form. Okay, remember that slope-intercept form? Y equals mx plus b. So m is always the number that's right next to your x. So here, our slope is +3. okay? Which means our parallel slope is also positive 3. So, for perpendicular, what it means is it's going to be opposite reciprocal. So right now, the 3, if I rewrote it, I could rewrite it to say positive 3 over 1, right? That means the same thing, that's just not simplified. But that's important to know that because that's going to help me write my perpendicular, because that's going to tell me, oh, I need the opposite sign. So if it's positive, mine should be negative, and I need the reciprocal of this number, so I have to flip this fraction. So if it's 3 over 1 for the regular slope, my perpendicular will be 1 over 3. And I can't simplify that anymore, so that's my perpendicular slope. Last one, last try on your own, and we will go over this next class. So if you have questions, write them somewhere on your notes so we can go over them in class, and then we'll do our practice, okay? That's it for today, guys. Thanks for stopping by, and I will see you in class. Bye.